Dear friends, welcome to another project video. Today we're going to use this small paper display with the ESP32 board and build a simple thermometer. It is a very easy project to build. It won't take us more than 5 minutes, so let's get started. Hello guys, I am Nick and welcome to Educates TV, a channel that is all about do-it-yourself electronics projects. In this channel, I share everything about the projects I built to help you develop similar projects or inspire you to start making things because it is easy, fun and creative. Subscribe to the channel now if you don't want to miss any future video. Let's see what we are going to build today. As you can see, I have connected a small e-paper screen to an ESP32 board. At the screen, we display the temperature which is being measured by this temperature sensor, the DS18B20. The temperature reading on the screen is updated every 5 seconds. The cool thing is that we don't refresh the whole screen, which is very slow, but only part of the screen which is fast and low power. Great, the project is working fine, but now let's see how to build it. The parts needed are the following: an ESP32 board, a 1.5-inch e-paper display, a DS18B20 sensor, a breadboard and some wires. The total cost of the project is around $30. You can find links to all the parts I use in the description of the video below. Let's now connect them together. A few days ago, we took a first look at this small e-paper display and we built a small project with it using an Arduino Uno board. Unfortunately, the libraries for the screen require a lot of RAM memory. The Arduino Uno offers a limited amount of memory, just 2 kilobytes, so we can build big projects with it using this e-paper display. So we're going to use something more powerful. Actually, let's use the most powerful board we have, the ESP32. As you can see, the ESP32 compared to an Arduino Uno is a beast. It offers two 32-bit cores which operate at 160 MHz, 520 kilobytes of RAM memory, Wi-Fi, Bluetooth, many analog and digital pins at a price of just $7. I prepared a detailed review of the ESP32 a few months ago. You can watch it by clicking on the card here. One of the most exciting things about the ESP32 is that even though it is so powerful, it offers a deep sleep mode which requires only 10 microamps of current. This makes the ESP32 the ideal chip for low-power applications. The e-paper screen uses the SPI interface to communicate with the ESP32 board, so we must connect it to the hardware SPI pins of the ESP32 board we use. It took me some time to find out which pins are the SPI pins on this board searching online. After I discovered them, I designed this to save you some of your precious time. You can find the pinout diagram of this ESP32 board in the description below. Now that we know the pins we need, all we have to do is to connect the display and the sensor to the ESP32 according to this schematic diagram. Luckily, all the SPI pins are placed on the same side of this ESP32 board, so we can use a breadboard to test our project. After connecting all the parts together, all we have to do is to power up the project. At first, the project displays a splash screen for 3 seconds and then it shows the temperature icon. A few moments later, the temperature reading appears. The temperature reading is updated once every 5 seconds. I have also prepared a version of the code with the temperature displays in degrees Fahrenheit for the friends of the channel living in the United States. The code of the project is relatively simple. We use the great GXEPD library to drive the display and a library for the temperature sensor. At first, we display the splash screen, which is a bitmap file designed in Photoshop. Then we display another bitmap file, which is the main graphical user interface of the project. The wiki of the screen has detailed instructions on how to load bitmap graphics on the screen. In the loop function, we read the temperature every 5 seconds and we print the temperature we read on the display. We don't refresh the whole display because it takes a lot of time, only the temperature part using the partial screen update function. As always, you can find the code of the project in a link in the description below. The project works fine and it looks great. The e-paper display is ideal for a project like this because it offers great readability and extremely low power consumption. When the screen is not updating, it needs only 0.02 mA of current. The ESP32 board needs around 60 mA of current when operating. In the next video, I will try to reduce the power consumption of the project. The goal is to make this project be able to run on batteries for months. To achieve that, I'm going to learn how to put the ESP32 to sleep, to conserve power, and I'm going to use another ESP32 board, the Firebeetle ESP32 by DFRobot. The creators of the board claim that this board requires only 12 microamps of current in sleep mode. So, in theory, the DFRobot Firebeetle board with an e-paper display will need only 0.03 mA in sleep mode. This means that we can easily make this project last on batteries for over a year. I can't wait to try it and share my results with you. I would also love to hear your opinion about this project. Are you going to build any projects with an ESP32 and an e-paper display? Please post your ideas in the comment section below. I love reading your thoughts. If this is your first time here, I would love to have you subscribed. In this channel, I post videos about do-it-yourself projects twice a month. I love making things and I believe that anyone can make things, anyone can become a maker. That's why I created this channel, to share my knowledge with the community and learn from the community. I hope you will join us. I'll see you in the next video.